and then that would be everything that multiplied.
Okay.
Medieval war.
Is this one that, nope, it's not the one I destroyed on the
That's a
lathe.
freaking jousting out.
I accidentally like put the plastic on the lathe and it like sharpened it.
I want to discuss the number 8, the one from this. So the purpose of those questions is to get you to think.
That's dangerous.
Yeah, we don't want thinky winkies.
Oh.
So 8 gives us, the first question is very easy, hopefully. If you don't think the first one's easy, then that means you're maybe a little lost. But hopefully this will alleviate that. What's the integral of f of x from 0 to 5? Well, they gave us a graph, so all you got to do is find the area under that curve between 0 and 5. Okay, so go ahead and calculate that. We'll compare answers in like 15 seconds here. I'm gonna split mine up like I see a triangle, I see a rectangle. So if I count all this up, my picture's not very good, but
9.
I got 9. Is that what you guys got? 3 plus 3 plus 3. 3 plus 3 plus 1 plus 1 plus 1, whatever, however you want to do it. All right, so we feel good about that? Okay, now B, there's 2 perspectives you can take on B that I'm trying to get you to think about here, which is just thinking graphically. What happens when you multiply a function by 2? What are you doing to the function? I wouldn't use the word shift. It's more of a stretch. So every y value is getting doubled. So if you think of this as a stretch, then what's really happening is, like, for example, how tall is that plateau now? It would be 6.
Yeah.
But the x values aren't changing. So, and then the second little plateau would be at 2. And so here's the thing. I don't think this is necessarily it's not like we're gonna draw this out every single time we're asked a question like this. That would be pretty inefficient. But if you just reason out, what happens to, like, say, this triangle? If it has the same base but double the height, what happens to its area? It's double the area. How about this rectangle? No, same thing. How about every piece of it? So the idea is, if you're just doubling all the y values of the function, that would actually tend to just double the area under the curve. So the answer to this is 18. If you find that argument to be a little hand wavy, which it is, there's a very rigorous way to get the answer, which is to say, well, we know there's a property of integrals that that 2 can go where? Outside. Yeah.
Oh, yeah.
So the integral of 2 times a thing is the same as 2 times the integral of that thing. So this is the more rigorous way of showing why the answer is 18. Because this is equivalent to this. That's like a fundamental property of integrals. And then didn't we already figure out what this is? Yes, that was 9. We showed that earlier. And so 2 times 9 is 18. Does that make sense?
Yes.
So good? Okay. All right. So how about C? What do you think the answer to C is? Negative.
What is it?
Negative 9. If you want a graphical reason, it would be, well, that graph, when you multiply f by -1, it flips everything upside. It does a reflection over the x-axis. So now all that area we had before is negative. Or more broadly speaking, any area that was positive is now negative, and any area that would have been negative would now be positive. So But also, you can say this, the integral of negative f of x is equivalent to negative the integral of f of x. Everyone okay with that? So thus the answer is negative. Not too taxing, right? This is like fairly straightforward, right? Hopefully it's not like super difficult. Now, by the way, one of the reasons I'm emphasizing this algebraic technique is you're going to have a hard time doing f graphically or g graphically. So let's move on. Let's finish the whole.
For D, I just take a guess at what D.
Yeah, sure. What do you think D is?
Is it going to be like 19 or 20? Because if you're like moving it up 2, right?
Uh-huh.
And then just include your new area. I think 19.
19. Yeah. 19 is correct. So let me show you. So if you're Winslow, that's good. He is 100% correct for D. You can probably imagine why someone might think the answer to this is 11, right? No, it's 9 but the thing is, graphically, this whole function, basically, imagine like a little platform of height 2. The whole graph is like shifted up onto that in a sense. And so it's like, well, here's the area we had before, right? There's your 9. But now there's this new, this is 5, 2 times 5 is 10. So without doing any real, I mean, it still is calculus, but without doing any calculation really, you can know the answer is 19. But that line of reasoning can be pretty confusing if the graph is like, say the graph had some bits under the x-axis, that can be a little confusing how that's going to work out. So typically people will do this to analyze. They'll split it up into 2 integrals. Or at least they'll think of it this way mentally. Does that make sense? Yeah. That's how integrals work, right? You can split them up over addition. So we already know the answer to this. We calculated it on part A. That's 9. And this is just like this is like a baby calculus problem, right? Oh, integral of 2 is 2x. Evaluated from 0 to 5 would be 10 minus 0. Right? So everyone okay with that?
Yeah.
So to show my work even more bigly here would be, this guy would be, you plug in the 5, you get 10, plug in the 0. Is that cleared up? So in this case, it's like this information could pretty much only be gotten from the graph, and this information is just kind of a basic like calculation. You gonna make it, Kate? Poor Kate. Watch out, Jason. She passes out. Make sure she doesn't hit the floor.
I think we need 8
What?
a rain energy drink.
No,
sodium.
absolutely not.
Sody pops.
No.
Science.
That,
This is full of science.
You just take
Science soda
take
pops.
Science and you pour like
And
a 5-hour
pre-workout.
energy drink.
I've seen the results of her getting a sip from one of Thomas's. That is not.
Okay.
Let me hear you talk about energy.
That's you. This is her.
So E is kind of what I was talking about a second ago. It's not very easy to visualize shifting this function down a unit. As far as the area goes, not sure if you agree with me on that, but like to try to visualize this like, oh, the whole thing is shifted down, so it's kind of like this now.
So would you
It's just 4, right?
subtract some of it?
Yeah, so this one I think the easier way to understand it is to do exactly what we did here with our calculation. Is you split this up.
Oh, this one's weird, man.
This one's weird, or another one?
This one.
I
Oh,
forgot.
see, it's not too bad, right?
Yeah.
Right? It's fine. So what's this first term?
9.
9. That's again from part A. And then this guy, what's the integral of 1? X. So x evaluated from 0 to 5. Does everyone understand that?
Yeah.
Okay, so we've got 9 minus, okay, let's evaluate this thing here. Plug in 5, plug in 0. So what's my answer? 4. So just like this one, so you can think of this like, on this one, we added like a rectangle of area that was 5 by 2. And on this one, we're subtracting a rectangle of area that's 5 by 1. But just visually, it looks, it's hard to really see that visually. What's up?
Yeah, so I had 4, and then, because I was thinking just like the last problem, when you just add like 5 by 2, you take away 5 by 1.
Mhm.
And then once you drew it, I thought I was totally wrong because of that negative little patch of area.
Yeah, I agree with you. Yeah, when you draw it, it's not clear how that rectangle, it's not clear like where that rectangle is,
Like where it goes.
but it's there.
Not mixed, not.
Okay, feel okay about that?
Yeah.
So, F.
Why? That was the most random thing.
You do?
I just sing the ABCs in
You had to say.
Can you guys do alphabetization efficiently without singing the ABC song?
No.
Anyone? Can anyone flex?
Well,
Okay, good
Every
flex.
now and then.
I can.
Like, certain ones.
It's embarrassing.
It's like
I can start.
And then,
Well, it's like, for example, if I'm filing something or filing something, I'm like, oh, this is the letter T. I don't just instantly know that T is between, let's see, element of B, Q, R, S, T, U. So, oh, between S and U, I know where it goes
I think
now.
policy debate is helpful. Because we alphabetize a lot.
I don't know. I don't necessarily need to sing it, but I can start from like a middle ground somewhere.
Yeah, I'm not singing the song, but I'm just saying I have to like do that.
I used to, but I'm pretty. I don't know.
Capital T Bank.
Because they wanted the chemtrails to activate the mind control nanobots. So you sing the song, the chemtrails activate.
Chemtrail.
Chemtrail. I was part of the conspiracy.
All right.
I have no clue what
I don't believe you.
Q, R, S, T.
Wait, you want plans?
All right. Quiet down, quiet down. So F, that's not, it's not entirely obvious what happens what's going to happen to this graph if you add X to it. You can kind of reason it out. This won't be a great drawing, but like, for example, does this point change? Because if you think about adding X to a function, it means when X is 0, you added 0. When X is 1, you added 1. When X is 2, you added 2, right? So like 0, 0 stays the same. Instead of 1, 1.5, it would go 1, 2.5, because you'd be adding 1 to it. And then at 2, instead of 2, 3, you'd have 2, 5, because you'd be adding 2. Does that make sense? Like when X is 2, we've added X to the function, so when X is 2, you're adding 2. So what it would do is basically the first thing would be steeper. By the way, you can think of it like this. That line is the line y equals 3/2 x. If you add x to that, you get 5/2 x. Oh, Jesse, welcome. Welcome. So you have like y equals 5/2 x. And then this would be kind of steeper. And then this would, I don't know. I don't know if that makes sense, but it's not super critical that you can graph. What is this graph going to look like after you add x to it? But I don't know. If you think about it, it might click for you. It might sink in. But anyway, let's just take the easier approach, right? So, okay, this is the same as the integral of f of x plus the integral of x. Okay. Sorry to be a broken record. How big is that? 9 Is this something we can calculate with relative ease? Yes, it is. So this is gonna be 1/2 x squared, evaluate from 0 to 5. So we get here, we get 25 halves minus 0, right? And so what do we get here? We get 18 halves, so 43 halves,
Yeah.
or 21 and a half. Either one. Cool beans, does that make sense? So he contributed 9, and then this linear function, if you add a linear function onto this, it would add in 12 and a half units. Square units. We're almost done, guys. This part of it. So G, we're gonna split up the exact same way. 5. Okay. And so, once again, this is 9, we know that from the graph. This guy is gonna be x squared evaluated from 0 to 5. So negative 16. All right. How are our feelings about that? What song was that? Was that Designer?
Yeah, Panda.
Yeah. Oh yeah. That was a good song.
And then he fell off the face of the earth.
You did what?
And then Designer fell off the face of the earth.
Okay, so the rest from there, you guys can solve. I gotta give you one more little hint here, which is, and I think you guys will have no problem solving this on your own, Aaron. When you do 9, there's one extra transformation that hopefully we recognize, which is the absolute value transformation. So what's that going to do to this graph? It would make all the y values positive. So really all that does, if you're talking about an integral, is if you can kind of imagine this, like this little piece down here being flipped up, all the area would be treated as positive area, effectively. So when you break this down for the first question, you're going to find, oh, there's a little chunk of negative area, then a chunk of positive area, then a chunk of negative area. Well, when you're being asked about an absolute value of the function, you can just say, well, if that graph had been all above the x-axis, all of that area would have been positive. Cool beans? Okay, so that's it for me for the day. Shout out to the Grifster.
Just saw it.
Thanks for the 10 gifted. What's up?
You just saw him.
You saw him?
Yeah, he comes in for one on.
What a savage.
Goodness.